So there is another question in Q&A. Basically, does COCO support exploiting the tensor cores in NVIDIA GPUs for sparse matrix computations? Maybe this is for Julian, the question. Rodrigo, not Julian. Rodrigo, Julian posed the question.
Yeah.
Sorry.
I'm not 100% sure regarding all the different compute capabilities, but my assumption is that it is, and if it's not, it will become really soon, because AI is really important right now, and they have a really close collaboration with NVIDIA itself. So I will look it up in the documentation right now, but most likely, yes. Like I said in my talk, there are different layers of expressing parallelism, and if the tensor cores are available to through the driver and the compute capability, in principle, there is no problem at all of using all the features of the architecture once you express enough parallelism in and the data types are compatible with that. So depending on how you arrange your threads or teams of threads, that should automatically use the tensor cores.
Okay, thank you. Another question, I guess, for Tilen and Rodrigo. So what are the next steps of coupling this LAMMPS implementation of ultrasound code with load balancing stuff and COCOS? Are there any activities?
Yeah, so maybe I can start. So yeah, it would be really interesting to couple this to a load balancing library that they are developing in Jülich, right? Because in OBMD you typically get, and also if you're doing ultrasound, you typically get these rarefactions, and in the buffer regions there are typically less particles than in the region of interest. So it would be really advantageous to do the load balancing, because right now what we are doing in this, when we are developing the code, we are just using the usual grid partition of the CPU.
Press this room of improvement that you mentioned.
Yeah, this can also.
Okay.
Yeah, just to complement Tilen's response, like for the ones who were present here when he was presenting the density profile through the system, one can clearly see that in some parts the density is almost twice as high the mean density, and in other parts twice as low as the mean density. And this is a good use case, for example, for the staggered grid. One would have to fiddle with how often the load balancing acts in the system to define the new domains, but in principle, if it's not too fast moving, it should, just like in the example that I showed, be able to follow the system dynamics. And if that's not suitable, one can do a global method, so not the stagger one that I've showed, but the histogram method, and reset the whole simulation box. That needs more communication, but it's something that one could try to see if it provides improvements. And in the way that we are implementing it, in principle, it should work with LAMMPS standard models, but we have to see how that interacts with plugins and other modules, for example, the address or the open boundary ones. So definitely that's a really good case study, and it would be very good to see how these things couple together.
Okay, thank you very much, Rodrigo. And I think that there are no further Q&A questions. I would just remind you that there is a poll that we need to still fill out. I think that Nea, our project manager, will brief you with basically details. She just put it on. So I would kindly ask you to actually, before you leave, fill it out and And then this brings me to the end of this webinar. I would like to, in acknowledgement, thank CECAM, and in particular Sarah and the technical support for making it possible to present our activities within the MultiXscale, and actually to update the CECAM community of what's going on in this Center of Excellence, and maybe get in touch with us. This is one thing. Then I would like to, of course, thank all the presenters, all the other members of the MultiScale for, I think, this very interesting webinar. All the participants, also Nea, who just organized and everything, all the communication between us, that everything went smoothly. Yes, and let's just conclude here. And please, if anybody has anything to say, just say it now and fill out the poll. Okay, thank you.
Thank you, Matej. Maybe just since I was able to reconnect, I apologize for the busy morning. Thank you also from CECAM for making the effort to join this webinar series and present your activities to us. Yeah, I mean, let's stay tuned for progress, both on the MultiXscale side and on organizing new HPC-oriented seminars in CECAM. Thank you very much. Bye.
Bye-bye. Okay, oops.